Let us prove that root 2 is an irrational number. Since antiquity, people were aware of the numbers like 1, 2, 3, 4, 5, 6, 7, 8 and so on. We call it natural numbers, and of course we know 0 and negative numbers as well. Further, we know what do you mean by half, or we know what do you mean by 3/4 and 4/7 or 7/9 and so on. However, people were not aware of any other number other than those until Pythagoreans came. They had a problem. The problem was pretty simple. They got a right angle triangle. We draw it. And then they just join the hypotenuse. Of course, that's pretty simple. We got hypotenuse. And they took a right angle triangle with base equal to 1 unit and perpendicular is also equal to 1 unit. So hypotenuse will turn out to be h square equal to p square plus b square. So 1 square plus 1 square, so 2. And so h will turn out to be exactly equal to root 2. So hypotenuse is exactly equal to root 2. Now they know only the fractions like half, 3/4, 4/7, 7/9, etc., etc. So they need the integer divided by integer, or natural number divided by natural number. Now the problem occurs, how much is root 2 equal to? We know that, or it's easy to calculate that root 2 is approximately 1.41, approximately, or you can get higher accuracy as well if you like. So root 2 is equal to 141/100, again approximately, but they could never decide what is the exact value of root 2, or is it exactly equal to the fraction a by b, where a and b are integers. So what they must have done is let root 2 equal to p by q, comma p comma q are integer, and again if possible, then of course we can square it both sides and say that 2 equal to p square by q square. Further, here we can assume that p and q are relatively prime. P and q are relatively prime. Now if they are not relatively prime, we can cancel it out to the common factor, and so we will get p and q relatively prime, and turns out that 2 equal to p square by q square. If we multiply it both sides, then we find that 2q equal to p square by q. Now you see that 2q is an integer, whereas p square by q cannot be an integer as p and q are relatively prime. So they get something contradiction, and they say that there exist numbers that are different from the fractions like 1/2, 3/4. So this cannot be a rational number, or root 2 cannot be a rational number. So root 2 cannot be a rational number because 2q is an integer, whereas p square by q is a fraction and not an integer.